Yeah, so welcome everyone for cloud computing and big data, parallel and scalable machine learning and deep learning. Today we have a very interesting perspective on the cloud, something we call platform as a service in lecture 9, which in many ways builds on the infrastructure we have already revealed in lecture 8. So of course these are connected, all these different layers. And we will learn today a lot why this is the case, and of course why platform as a service also is an interesting topic, because it is essentially about software and libraries, as you will notice. So in a way, platform as a service is very developer oriented. It's about getting different Lego bricks, and I will clarify what I mean with Lego bricks, and create your house, your car, your boat, whatever it is. So it's really a platform where you pick different elements and basically create a higher level service, which you then can use for get some revenues. And we will see this in terms of apps like, Angry Birds or Philips, but also on traditional services like Twitter, for instance. But before we dive into the material about platform as a service, let us reveal a little bit what we learned in lecture 8 the last time. So what we learned in infrastructure as a service is really that basically all of the cloud services require some form of it. So whether it's computing, storage, network, this is every time needed when you actually access a cloud. It may not be visible to you, right? And then we talk about platform as a service and then maybe software as a service, because somewhere this infrastructure is nicely hidden from you. Of course, if you just want to have infrastructure as a service, this is very hardware oriented, as we have seen. So it's often related to which type of computing I want to have, the number of nodes, for instance, in an Apache Spark cluster and with master and worker. But also we have seen there different storage resources. We have seen the object storage, we have seen the block storage, and even on top of it, specific file systems maybe that are relevant. And with this, we have seen that basically it's just infrastructure, but already the name infrastructure carries a lot of load. And this was, let's say, the real beginning of cloud computer. If you look back, many companies had really their servers at home, so to speak, in the organization, right? So there were no clouds where you can just simply quickly compute. There are some data centers and computing centers already in former times, let's say big, large facilities, for instance, hosted by IBM or so. But largely, the whole industry had always servers. And what cloud computing now with this IAAS enables is essentially you can offload your servers into the cloud and then have lots of flexibility. And that's where essentially also the other topics start when you think about maybe platform as a service that we will reveal right now. Because another takeaway message really is from these levels, there is not a very precise, clear boundary. So like a mathematician would say, we define infrastructure as a service exactly like that, and every vendor has to admit to it. Because one of the things we also will learn today is that the vendors have actually quite a strong input in all of that. So you will see that Amazon, Microsoft Azure, all we know already, especially the Google Cloud, they have their modus operandi go forward setting standards instead of adopting standards. And that's what I will also tell today. But what you also revealed the last time here in infrastructure as a service, as you have seen that the S3 interface, which is very proprietary AWS services, so to speak, are actually adopted by a wide variety of other vendors. And of course, they want to do this to migrate maybe users away from Amazon to have a, let's say, better service offering. And let's say also to be, able to work with some of the Amazon services if you, for instance, create a hybrid cloud, as we also said, like keeping some maybe in the private cloud that I create with OpenStack or so within the company. And then I use the S3 storage interface just to store every now and then some data to AWS. We have seen the Glacier storage, for instance, was very cheap for archiving, which may be also not anymore, really relevant for the organizations, but still very good to keep, maybe for bookkeeping or for, let's say, not just the sake of losing the data. Of course, normally you would say you have a wild mix of all of these cloud services. And again, people in the companies today, they don't really differentiate that much anymore of IAAS. Given there's a lots of evolution of all of these services, we see more and more over the last, let's say, 5 years, that these boundaries really vanish. And I think a good example of that was when we talked about MapReduce the last time, where we think about, you could actually think about IaaS very much when you say you have a bare metal installation, you basically have it totally done yourself, right? So this is an infrastructure as a service model, so to speak. If you want to provide this, then people can install MapReduce themselves. Or we actually have a MapReduce appliance, so using already a little bit the power of virtualization, as you know from lecture 4. So they're basically some images, some instances that people then can deploy and run. But it's still not, let's say, the full power of virtualization, because we have also learned with basically running a service or deploying already services within the cloud is a big business model. By not already setting up MapReduce with an image yourself, you really just automatically deploy it with a number of worker threads or nodes, more particularly, that you really require. And at that point in time, you may cross a boundary. You would say, well, on the one hand, we have still infrastructure, so MapReduce is an infrastructure, but on the other hand, you would say it is already a platform, because we can develop things on the MapReduce framework, as we learned, which essentially uses things like the keys we had, or the map, let's say, sort, shuffle, group, reduce applications, if you remember, where we had word count. So that means essentially this service is already running, but people have to still develop, let's say, maybe MapReduce applications and so on. And then when you go to really completely clouds, and where you really maybe have already something which we would now end or start to discussing here in this whole course today, will be clouds as a platform. So you would have a MapReduce as a service, and essentially what you do is you use maybe Mahout for machine learning, you use other systems around MapReduce. If you remember, many of these, like Apache HBase, I will go in detail a little bit in this lecture today, is a NoSQL store, which is quite interesting. And I know NoSQL doesn't mean anything to you, but we will see how that materializes when we talk about this. Document stores, this key value stores, they're also sometimes called new approaches to data, really. And if they all work and interact with the service, you could argue that MapReduce at that point in time is not solely infrastructure, it's a platform to develop lots of interesting services and applications. While having also revealed all of that, we will continue, as we have done the last time, to always here and there think about some prices. Of course, I think it's getting boring to do that now every time, so I will here and there leave that out, that prices matter, but you can think that usually everything which I explain here in terms of services have some form or another, really some costs related to it. There might be several elements which basically are, let's say, for free. But as we have seen, for instance, here for this API access, for instance, if you really want to access S3 as, let's say, a storage that you really actively want to use with your app, you have to pay for every of these 1,000 requests, even if it's just a couple of cents. But then now when you think about an Angry Birds, which has, an app with an unbelievable amount of users, then of course these really add up, these costs. And you have to really budget that. And many of the startups that we have seen and basically explored, like Voodoo Games and maybe many others, I also have done 2 years ago, shown how their business model were. They under-expected perhaps a little bit the cost, what that means really to use a cloud. They have very powerful services, as we will reveal today. All the platform as a services, application examples are quite interesting and carry away really the message that less needs to be done from the developers in the company. But of course, this is loaded because you don't have to hire the developer, but you have the service costs and eventually 24/7 running in the cloud. However, there are lots of benefits still, but as a university course, of course, we always have to be really neutral here. We have to look that this is a very great idea for organizations to really scale up to many different users, to quickly grow to many of application sectors they would never ever touched before. And on the other hand, we have to also see the disadvantages. You maybe are getting locked into a vendor. With the infrastructure as a service, that's something which is not that strong yet. We said S3 is an interface that many adopt. EC2 is, let's say, in the end, just computing, and I do an SSH into it. I maybe can do an SSH somewhere else. But when we come now to the lecture of today, when you think about platforms, when you think about software will be really implemented from developers, you can imagine that if they use the Lego bricks, which are, let's say, very vendor specific for Amazon, you cannot just port this application very quickly away to Amazon or to Microsoft or to the Google Cloud Platform, as we will reveal today. And with this, we basically have alluded to already to many interesting topics of platform as a service. In many ways, it is really an advancement of software development. You can see that. Also because it's really largely grown significantly together with elements we will reveal in lecture 12, essentially. When we talk about Docker, container, we'll do some links to Kubernetes, different tools which really enable significant deployment quickly at scale, which we will not talk about today, but on lecture 12, but these things are connected. And of course have also contributed to the fact that the clouds have so enormous uptake. So when we talk about the two parts that we have today, I really want to give you over the message that Lego bricks is a key idea of all of this PAAS. So having all of these bricks ready, and you just need the right one to fill some certain gap in order to maybe finish your bridge, finish your car, whatever service it is. Of course, it's an analogy, right? Clearly, but I think it's a very good explanation of what it is. Then when you think about PAAS, in the building blocks, there's more to it. We will see that's about environments. So if you think about Lego bricks, think about the plate where you logically put the Lego bricks on to develop something. Even if it's a water plate to have basically your boat, being on water, if it's a blue one, or if it's a gray one, then it's on stone. Again, a simple analogy, but it really carries a lot of essence. It's not only software and library that is there. That could be done by virtualization, right? That's something, or maybe even with containers we will see in lecture 12. But the point is here also the whole ecosystem, the lifetime of a software is supported. You have integrated development environments, and these at scale, integrated directly with Google Cloud Platform APIs, of course, to adopt those. And with this, you have a huge amount of possibilities. And of course, this university course, as one lecture, cannot cover all of them. But one particular one I want to pick out are the NoSQL stores, which are getting more and more momentum in the last 10 years. And of course, we will look on some differences between the structured query language and this NoSQL databases. And of course, here and there, we have this interesting Google App Engine, which again is an interesting service approach of Google, and some pricing models with applications along the way. In the second part, then we will look at much more advanced topics, and there we could really talk a whole university course about, again, the landscapes that you will find in Amazon and Microsoft, in different clouds, even if they are smaller than Google and others. But here I try to pick different pieces, firstly for software development. So what is the role of software development kits and APIs? What is the role of queries? So if you think about, lots is about searching information, and this nicely also connects to the NoSQL stores. Lots in the cloud is about searching, more reusing data. This is already there. It's less about writing data. So we see more and more that these clouds are in a way a little bit reading optimized with some of their platforms. So I picked a little bit around those, and of course also around some interesting application examples like Twitter or IKEA. And the other part I wanted to convey with the second part will be, of course, thinking about machine learning and deep learning, what our course is about. So we will talk a little bit about natural language processing. We didn't touch that topic yet, and sentiment analysis for an example, but also, of course, our traditional ideas about deep learning and machine learning. We end a little bit, as I said, also with specific interesting aspects of this PAAS approach, which go beyond the infrastructure as a service when we talk a bit about risk. So of course, one is an opportunity to use a Google Cloud TPU, a tensor processing unit, and we will look lights on it. And it's a very specific hardware-oriented service, which you in a way can see as a platform because it's really a kind of vehicle to get deep learning faster. On the other hand, you see, if you have this, it's just Google that offers this. You cannot buy that, right? So in this sense, we have to talk about some risks of the disadvantages of the PAAS approach. And this is significantly with the vendor logs that we observe. And we will also reveal some ideas of doing standardization, but this is by far underdeveloped in the cloud. So there have been standards in the past, OCCI interface from the Open Grid Forum. There has been S3 rather as an de facto standard than real standardization happening. And this is something we really have to explore when we talk about the different vendors. So let's see a little bit this PAAS approach. And of course, before we go into this, just quickly let us reveal what we had talked about this. We really are here, if you see the laser pointer now, here essentially in the middle, right? And with this, of course, the boundaries to the upper and to the lower layer are somewhat confusing. You can always say, is it not that already software as a service? Or is that not more infrastructure? Remember about the MapReduce approach. However, they have all the different unique selling propositions in a way. And another way to understand it would be maybe that you really have this developer focus in mind when you talk about platform as a service. I put here another very nice illustration which shows you a little bit the boundaries from another perspective that you have here in the middle. Basically, this interesting PAAS we talk about today and what it really adds to IAAS in a sense, where we said it's lots of data center, computing, networking, service, and storage. What it adds to this is really the thinking about development tools, database management. So database as a platform, so to speak, as you already see a little bit here, database as a service. Okay, that was infrastructure, but still, I think in many ways you could also consider this almost as a platform. And then there's a huge section of platform as a service, which is towards business intelligence, data analytics, business insights. So everything which is indirectly related to your software. Basically, it's not really user-facing. It's, again, developer-facing, doing analysis, maybe some machine learning to learn what users are doing, which levels of Angry Birds are best actually or often used. Maybe we create more levels which are like that. So this is, of course, something business intelligence, business analytics, which is a huge market, but is related to a different type of people using that. And I think PAAS is best understood if you really have a developer perspective on and think about what I have to do, as it's shown here on the right-hand side, to make a nice client interface where people have to, maybe pay me something. So I have to have a billing service somewhere in my platform. I have to monitor the quality of my app. And I want to have launching some tasks that are related to, of course, maybe loading some data out of the database, could be the level, right, that I have in Angry Birds. And then I want to interact with some enemies in this interesting pigs which are running around in Angry Birds, and the birds doing some interesting properties and using their unique capabilities to actually go against these pigs. So essentially would say you as a developer have the story of the application, and you use this different Lego bricks basically in the platform that help you then to deal with the infrastructure, but then also to prepare something nice for the software layer later. So much for the perspective, really. If you think about PAAS as a service, it's an important thing to really understand that. While infrastructure may be much more towards administrators of systems and so on, this adds basically a lot of points to the development, because as you see also, infrastructure as a service is here compute engines, and you find this of course also in the Google Cloud. I just put this in because we largely had this always in Amazon. Of course, also Google had IAAS examples in computing, and no surprises here, right? You see compute engines, and what's the key technology enabling it? It's our VMs, again from lecture 4. That's why it was so essential. We've seen cloud GPUs, as we revealed in lecture 6 and 7, very important for machine learning, deep learning, of course also for graphics, visualization, and so on. All the ideas we had with migration and different aspects of VMs, you basically also have in the Google Cloud. And with this, of course, then the Google Cloud Platform, which is enabling us now to think about platform as a service products, they are built on top, leveraging again VMs. So of course, they don't want to go quickly and using Amazon services, but of course, through several models, they can by having an S3 interface, for instance. So how that would look like, and I told to you that in a way, it's developer-oriented, and every developer knows that behind development is, let's say, lots of activities, which means a life cycle of software. A local development, maybe that you first start with some software development kit, you build, you code, you upgrade it, and then you deploy and test it in some, let's say, cloud-like environment. And you do this in a local development part. And what you also know as developer, you have certain Lego bricks usually, right? Also, if you do local development, you have several libraries that we put in, like scikit-learn. If you do machine learning, that could be a Lego brick. But of course, when you have a platform as a service, you want to have something working in the cloud. So essentially, you pick those libraries or these Lego bricks which are there and combine them in order to run on the IAAS, on this infrastructure as a service that we see here on the bottom, in the Google Cloud, some specific application. Could be games, as we see here, Voodoo, Quiz Run, or Angry Birds, or Philips, these standing essentially for the lighting, right? It can be app controlled, how much you steer the lights and colors and so forth. But these are really just examples. If you go to Google Play, you will see hell a lot of those, and of course also to other repositories. Largely by far, they have all in common that they have some user interface and an HTTP request that then really has to scale to the number of users. And this is where the Google App Engine, for instance, helps. It helps for once for really being scalable. So to really quickly running out of the Google Cloud infrastructure without you have, as a developer, think about it, that Angry Bird suddenly has, instead of 100 users, maybe 100,000 users or 10 million users. And then, of course, have to think about, I have to deploy much more resources. That's done basically more or less automatically underneath. Then the whole monitoring. Once you're a developer, you want to know, is it actually performant, or are my Angry Birds not really running? Are they, let's say, almost, standing on one pace because it's got them slow? I have so many users that my application doesn't scale anymore. So there's monitoring. Did I do something wrong with loading maybe the level data quick enough, or did I use the right tools, right? Lots of these things in PAAS will come exactly to this point. Do I pick the right Lego brick for my problem? And of course, what helps me to realize this is traffic monitoring and so forth, and maybe changing different versions. But also there, the App Engine helps enormously. And then it really carries the environment. So you have lots of SDKs. The whole life cycle of development is supported, and I will give some examples later. So basically, these called fully managed serverless platform. I don't like that term so much because we know all that in the way it's server based. So there are servers in the cloud. So saying serverless platform is a bit misleading here, but what they mean by this is, of course, that you as a developer, you don't care about these servers anymore. You have basically your complete engine. You can deploy, you can develop, you have SDKs, APIs. So you can just be completely focusing on that and neglecting everything we essentially learned in IAAS, except maybe swiping your credit card, because of course this has to be paid, right? The interesting thing is really, again, if you think about what we learned in infrastructure, again, that a platform also should scale to its users, meaning not only, of course, that developer teams can use this, right? So maybe geographically distributed teams can take advantage of this, but also, of course, again, thinking about many of users. While I still, again, would say planet scale, what they put out here is a bit let's say, provocative. I would like to see that if all on the planet would use it in an instance, but still, you know, it carries a meaning. And of course, Google has a certain means behind it to really think about deploying really at scale infrastructure. And of course, this is now really convenient. If you're a startup, like let's say Angry Birds, and you had some misplaced app in the past, money's getting low, you don't want to have a big server infrastructure in your own house. And so this is, of course, thinking about that you not only have then also the developers and administrators that install all the software, it's just ready to be used. Now, what is this Google App Engine? By now, I think you have a certain idea. It's basically based on the compute aspects and network and storage we have seen. It has lots of built-in services, so it's not only essentially one service, it's a whole environment. And I think that's good to see it. And the way to really think about it, that the scaling automatically is important and has lots of different services that, you know, using just the Google or reusing just the Google infrastructure again. And has lots of programming languages support. That's, of course, where developers are interested in. Java, Python, of course, and others. And when you look on the business cases, it's really impressive that more and more actually adopting this, and they have interesting user stories also behind it, where these are all from different, let's say, point of view. One is that they have 30 terabytes to work with, is an example here of this eDEX. And then thinking about, again, what it means in terms of doing it all on your own, on premise, then you maybe have $500,000 more cost. So you see, often the cloud has significant savings if done correctly. So let's look through a couple of those building blocks and think about how could you realize an application with it. So here's an example how you basically have the similar thing that we also discussed in the Amazon platform, basically, or the Amazon infrastructure as a service, when we said we want to do a web application with static and dynamic cloud content. Also here in the Google Cloud, you basically have with the App Engine all what it needs to really create a web application for doing, let's say, dynamic content, which you get of the highly optimized Memcache database that you don't always, you know, the cache is really helpful if you have similar queries. Again, you have task queues to work a little bit on your data stores. And then, of course, lots of things are basically around your website, logging and monitoring. You will see here different services like BigQuery. We will go also later in an example, and together also with BigTable, which is often used together. So the idea is, again, scalability, right? And now one of the most interesting application examples here for us is, of course, thinking about the App Engine, right? In terms of games or something like this, which has really a massively growing user experience, and then with this it can really scale. If you don't do it right, your users don't grow, and then you don't have to scale, but the chances are you're running out of money and get bankrupt. So you see that incredibly often in some of these use cases where a startup is coming. And I think Voodoo Games is an example I can tell from experience. We had 2 years ago as a game with quizzes, and you find now on the web that actually they went bankrupt. So of course, startups try to do this, and it's a very good way of doing it, but perhaps some of them really don't overlook and do budgeting of the cost, what it means to not get the revenues from the app stores for you, but keeping them aside partly at least, not only for your developers, but also for your infrastructure that you buy or rent, more to speak. So again, here you see it takes any time, again, the Lego pieces, the MEMS cache you have seen somewhere else, right? In a complete different example about the web application. Now we're using this again because it's always been getting some basically queries that you maybe want to store and reuse, and then you have a data store again. Again, you would see, of course, applications are similar. They will use data somewhere stored. They have a publishing and subscription model somehow to make notifications work. And, you know, queries, we want to see in our flows of data some queries. And of course, then lots of things about reporting and so on. So in a way, we see again and again these Lego pieces reused. And when you think now about the pricing, and I highlighted some of them here, when you think about the pricing options, again, you see the incoming network traffic is here free, interestingly enough, but the outgoing network traffic costs, right? Of course, this is somehow understandable. If it's free, then you maybe migrate from a different cloud provider, but once you're basically inside the cloud, you have to pay if you want to migrate to another one. Or search. By far, many applications in one form or another need search in a way, and we know it's actually not that easy to search in a very high performant way, especially if you have growing amounts of data. Like, think about Angry Birds has not only one level, it has many levels, it has many apps, it has many users, so more and more to look through. And if you have here per gigabyte storage, you go and pay the price for it. Still, of course, doing that on your own, create a search engine on your own, which is high performant, will also mean something. So in this sense, you really have benefits. But another essential part of this lecture should be really the NoSQL databases. And many of them know them by now. It's key value stores, highly optimized, essentially, because they don't have this constraints and the consistency as typical SQL databases. So structured query language usually has table schemes or schemas. You create this SQL database tables, and then you have the same attributes for everyone, and lots of different consistency models that I cannot allude to, because then we need a whole, basically, DBMS, database management system lecture. But essentially saying that the NoSQL relaxes some of these facts to be non-relational, basically, and to also then thinking about, for specific users, not updating data a lot, but much more reading, and quickly, based on my key value store structure. So this is the idea of this, and you can see it as one Lego brick in the old example. Philips is a good example of this, when you have lots of these devices where they basically just have to read and see lots of information, what you can do with these devices, where they are deployed. They essentially using basically the cloud like this, and have lots of millions of transactions. And of course, they don't only use a NoSQL-based Google Datastore. Essentially, they have also different ones and different services they use, but I just highlight here a couple of them. The interesting thing is, of course, also when you think about how much more Lightning you can connect to it. If you have heard about it, you can connect their different lights to one certain central hub. And with this, basically, you can see that each user in a way can also then scale up. And when you want to have an infrastructure that copes with all of that in a very smart and efficient way, essentially then you need something which has really powerful cloud computing on the back. And we see here, it's 10 times the scale of other similar project with 1/10 of the workforce. You see, so processing 25 million remote Lightning commands per day. I think this sheds a little bit about the light what you otherwise would have to do in your own organization, meaning Philips. And Philips is not the expert in cloud computing. They do customer services, customer products. So when you think about NoSQL features, like I said here, it's really for automatic scaling, high performance reading. It has, of course, interfaces similar like SQL databases, but it's more optimized for APIs and REST calls, less to SQL schemas and so on. And often, basically, they're really powerful query engines that we will see later also in this course hours here, which is really optimized for scale. And this is a nice comparison, if you want, where you have the cloud data store is kind of a type of object, and in a relation database it would be a table, a customer. In a cloud data store here, which is a NoSQL, so it would be some form of an entity, it would be a row in the relational store, and so forth. So in a sense, it's really optimized for APIs, highly reading, but the best way to understand and differentiate is really that they have specific properties, and one of it is really that you think about not all of them have the same data, right? If you think about a typical relational database, it would always all information for everyone, but a key value store, as it is shown here, essentially has, let's say, just a couple of fields for certain elements. And then you can go to this general Characteristica, where, Cloud BigTable is there, for instance, as another service, implementing lots of different aspects of this NoSQL, but for a very specific way. So for instance, string-based approach to NoSQL. So if you go to the details, you will see essentially that all of those have much more hidden gems in the details. There are many different NoSQL data stores. Here's an example of using machine learning for finance, where again, the NoSQL is of course playing a huge role. We don't want to write a lot of stocks information. We want to read, right? That's a key issue here of putting it to some form of machine learning, data analytics to understand much more of the stock market, maybe also related to, time series in terms of maybe news about companies, which are also relevant. So the data model, in a way, partly is related to what you already know from Spark and so on. In one of the lectures where we had the storing of web pages, where there would be, let's say, lots of links when you have the web pages here. And this is exactly where essentially such a kind of key value store really becomes in handy, because you always have the same structure of web pages. And then if you go through, you can really make an index out of it. And this is how Google BigTable began, right? They wanted to do this. But just to contrast both of them, essentially, this is a topic of its own, and we need, let's say, a couple of lectures to go really to all the different ways how NoSQL is done. But its SQL databases are really good for structured data, right? While NoSQL data status you use for unstructured data, things where you like here have not all the information for everyone, and doesn't matter maybe, right? And then basically you have not really a schema, you have a relaxed consistency requirement. So for a string, maybe it doesn't matter if you put null in, right? So normal SQL database may have a problem with this. And if you think about that, this is of course a very general building block that you can apply incredibly often in many different applications. You can also see that there have been different flavors of it: column-based, document-based, key-value-based, graph-based, that we will look a little bit more in lecture 14 then. And there's a huge way around all of these different ones that you see on the right, used for different purposes, really. So let's go a couple of them as short examples, because they will also come again in the lecture, or we had them already, like Apache HBase we already used essentially, where you have then again a key idea of this together with certain timestamps of changes, of course, from these web pages over time in the web, and different, can say, conceptual views, which then really help to make the performance, while the physical view is really that, for instance, here no empty fields are stored. When you compare to the relational database, also empty fields would be stored, which is, of course, basically not really possible or done in all of these NoSQL stores to save space and to optimize it for read. I also said it's developer oriented, so you find several different interfaces. Here's a JSON, which stands for JavaScript Object Notation interface, so to speak, how you have, again, the kind of ID and the information. So again, it's a key value oriented structure. Of course, a little bit different in the Mongo database. And you see here the data model is really on JSON, but you can also integrate it in C++. But the look and feel is, of course, different, and a different way how really a developer is using and interacting with this. And the similar is true for Cassandra. It's just yet another example, which is a bit more smart, working with hashes, and essentially have lots of ideas of using this hash values then really to optimize the keys that you have and to put the placement in order, thinking about that these could be also distributed databases, which the data is of course alluding to. And it's also used at Twitter, eBay, Netflix, all the big giants, of course, incredibly often to manage the read load, not the write load. And in a way, I could go on. There are many other NoSQL databases, but that's not the point of the lecture. The lecture is just to realize that there are actually platform Lego bricks that are going beyond the traditional DBMS SQL scheme, which are really hard-coded, like Oracle SQL databases here and there in organizations. In the web, lots of things are for reading, and so they are really good at this. If you're interested more into the App Engine, of course, here's a short video. Also, there's lots of resources that you would have essentially on YouTube or also on the Google Cloud Platform. So that's it, and we break here for 10 minutes.